ওয়েদার কেমন এখন?
Ladies and gentlemen, welcome you all to GAABESU's first ever Research Award presentation program. I would like to take this opportunity to convey our thanks to our institute administration for giving us the opportunity to support deserving students of IIEST through this program. We are certain that the existing model of such an interface between alma mater and her alumni communities will grow from strength to strength. Our alumni have played a significant role in upholding the legacy and branding of the Institute in the Global Technology Forum over the decades. To name some of our contributions towards infrastructure enhancement and student welfare related projects, renovation of century-old heritage GAABESU's gymnasium that was done by 1961 and 1971 and few other alumni, college history plaque, class of 1974, new second gate, class of 1983, rebuilding of swimming pool that was done through an open contribution from BEC alumni located all over the world, GAABESU guest chair professorship by class of 1981, Slater Hall renovation by Unoashi, class of 1979, video documentary on our alma mater, alumni seminar hall with state-of-the-art audiovisual equipment, very large-scale integration VLSI laboratory project, BECDU Beka Land, Promoda Lodh Laboratory, chair professorship in the Civil Engineering Department, a floor of science building, Bonkim Lodh Block, Young Faculty Research Award, Madhusudan Bhattacharya Memorial Fund being used for Research Award by GAABESU, BK Bose Lecture Fund, Students Reward Program, GAABESU Admission Grant, Roy Saheb Amulya Chandra Mitra Endowment Fund. This was by Shyamol Kumar Mitra, Civil Engineer, 1967. Financial help to students of SAE for their national competition through alumni donation. Financial help to innovative projects by IIEST students, which are for the benefit of the society. This was by Nipendra Chandra Acharya, based out of US. Travel grant fund based on contribution by class of 1987. Alumni scholarship program, it's a kind of flagship program of GAABESU. Alumni link, that's a magazine, a newsletter to keep us connected and informed. We have recently taken up Vidisha Lake beautification project, alumni guest house annex project. These are the two ongoing ones we are working on jointly with IIEST authority. Improvement of hostel condition. This is something which we have in mind for quite some time, and we are going to take this up soon. One-time support to needy students for their tuition fees. This was also by alumni donation. Discussions are on with IIEST for possible alumni support in improving NIRF, which is a national ranking, and QS, which is a global ranking space. We observe Global Alumni Day on the last Sunday of the year. We started it in 2014. It's a gathering of alumni for all over the globe. It is a platform of our alumni and their families to celebrate the reunion, exchanging ideas on promoting excellence and welfare of our students, implementation of new education policy, NEP, of Government of India, challenges in engineering education in virtual mode, encouraging research work as well as infrastructure project of the Institute. All these remain the central point of discussion during our Alumni Day celebration. Please let us know if there is anything else that could be done to strengthen the bond between the graduating students and our alma mater. Requesting outgoing students of IIEST and our young alumni to join GAABESU and strengthen our hand to serve our alma mater. Thank you. Today's program, we have Nihar Dr. Nihar Biswas from Windsor University, Canada, who would be moderating today's session. Nihar, over to you.
Okay. Thank you very much, Madam President. Welcome, everyone, particularly our distinguished alumni and all our students, particularly the students. Yeah. Just a few comments before we start our presentation is that the process itself in the selection of the best paper from the research done by a panel, a group of 3 or 4 of us from GAABESU, and we review the applications, and that's how the selections are made. Just for the students, the benefit is very obvious. Undergraduate research is extremely important. This allows you to hone your critical thinking skill, literature search, experimental design, numerical analysis, and of course, you can find out what else is going on in that particular field all over the world. And this communication skills is very important because that's where, as an engineer, it will be absolutely invaluable for you. Other goal is that this will also sow a seed in your mind for higher studies, possibly in India or abroad, because research is a fundamental base for almost all innovations. So today's protocol that we have in mind is that everybody will get an opportunity to make their presentation. It will be 8 to 10 minutes. And after you finish your presentations, we will have an opportunity to have 1 or 2 more questions. And we will just follow the schedule that we have already prepared. So right now we have in our list, the first project is Ayona Biswas. And Ayona is a winner, is a ME 3rd year, winner of the Gauri and Jitendra Mohan Majumdar undergraduate fellowship, donated by late Professor Jyotirmoy Majumdar, 1972 MET, metallurgy, from University of Michigan, Ann Arbor. Ayona, are you ready?
Yes, sir.
Good. Over to you.
Sure, sir. Sir, can I present my screen now?
Yes, you can.
Yes, you can.
Only host can present the screen. It shows now.
Oh, okay. Tul.
Yes, I can present now.
Yeah.
Give us screen sharing.
Yeah.
No such option like screen sharing.
Yeah.
Oh, I know screen. Okay. I hope I am audible and you can see my screen now.
Not yet.
Not yet, but we can hear you. We can
Okay.
hear you, but not the screen.
Ayona, if you have any problem, We can share the screen for you, your presentation.
Okay, ma'am. Then you can share the screen.
So Duldul, will you do it?
Yes, ma'am.
Okay.
In that case, Anna, please try to show yourself.
Yes, sir.
Can you see this?
Yes, ma'am.
Yes.
No, the presentation is not visible.
You can't see the slides yet. But
We can only see the list of presentations, but not the.
Yes, we have not seen.
We haven't been able to open the PowerPoint presentation as yet.
Amitabu, will you take it? I don't know. I mean, from Duldul's machine, maybe it's a heavy file.
no, I think she chose the wrong.
I think so.
Okay, sure.
এবার দেখা যাচ্ছে।
Yes, now it is all right.
Oops.
Now
I think too many people are trying at the same time. Okay, good to go.
Yes, sir. Hello, everyone. I am Aina Biswas, third-year undergraduate student of Mechanical Engineering Department from IST Shibpur. The subject of my paper was potential of a solar organic ranking cycle in India. Next slide. Hello.
Okay.
Can you go to the next slide?
We can see the next slide. Continue, please.
Oh, you see that? Okay, okay.
The background slide.
Okay, you can show the, okay. Renewable energy sources, especially solar energy, has immense potential as there is a global requirement of meeting the required energy demand. Over last few decades, India has experienced exponentially growth in energy production and demand due to the rapid industrialization, population growth, and globalization. Due to the challenges existing with conventional energy production like carbon dioxide emission, non-renewable energy resource depletion, and other associated with the environmental impact, government has its primary interest towards the alternative clean energy production. The clean energy production is predominantly based on the infinite renewable energy resources like solar energy, hydro energy, wind energy, biomass, and geothermal, etc. Based on the data disclosed by the Ministry of New and Renewable Energy, the Government of India, presently India has achieved a massive 226% increment in renewable energy installation and has a 25.64% of share in total installed capacity. Furthermore, there is a plan of achieving 40% of its share in electricity production within 2030. Notably, amongst the available renewable energy resources, solar energy holds the large share for its availability almost in every location. Apart from the clean electricity production, this source of energy is also effective in district cooling, clean hydrogen production, desalination, etc. As a result, a National Institute of Solar Energy, Solar Energy Council of India, and several other industries are making a constant effort for diverse the use of solar source. There are two major ways of converting the solar energy into electricity. One is by direct conversion of the energy for electricity production employing solar photovoltaic cells, and another one is converting the energy into heat, further using it for electricity production. Now come to the highlight. Next slide. In this present paper, the various scenarios are articulated where a solar organic ranking cycle system can be a good alternative for electricity production. 4 organic working fluid are shortlisted based on 9 indicating factor, and evacuated tube solar collector is used as a solar collector. Furthermore, a comparative analysis of fluid using 2 scenarios is conducted based on the power requirement approach. Next slide. Now come to the methodology part. The solar organic ranking cycle consists of 2 circuits. One is the organic working fluid circuit, and another one is the solar heating circuit. The main component of circuit consists of solar collector, thermal energy storage, circulation pump, expander, evaporator, condenser, working fluid pump, working fluid, heat transfer fluid. The organic working fluid circuit consists of 4 processes. Process 1 to 2 is processed through the pump, where the working fluid is pressurized. Now the process through the evaporator. The pressurized working fluid is preheated, evaporated, and superheated by taking the heat from the water of the evaporator, and the working fluid reaches the maximum temperature of the cycle. Now the process through the expander or turbine. The organic working fluid enlarges the turbine, and the mechanical energy is converted into the electrical energy here. The superheated working fluid is cooled in the part condenser and the saturated vapor condition at a variable temperature in the desuperheater, and the saturated vapor is condensed to the saturated liquid in the condenser. For the solar heating circuit, water is used as heat transfer fluid, and evacuated tube solar collector is used as solar collector. Now come to the next slide. Next slide. Then next slide. Yes. In the thermal analysis of the overall system and the subsystem is based on some assumption. Those are all components are in steady state condition. No heat loss and pressure drop will occur in the system. Change in potential energy and kinetic energy is negligible. The working fluid at the outlet of the evaporator and condenser is in saturated condition. The pump and the expander are adiabatic in nature, and the constant isentropic efficiency with constant isentropic efficiency. Now the next slide. In this present slide, the mathematical formula of power consumed by the working fluid pump, total heat transfer rate in the evaporator, mechanical power generated by the expander, total heat rejection rate of the condenser, net power work output, and the thermal efficiency are expressed. Then next slide. The heat which is received by the solar collector and transferred to the heat transfer fluid can be calculated based on the collector energy balance expression as a function of collector efficiency. The mathematical formula of thermal efficiency of the solar collector can be expressed in the term of solar irradiance, which is denoted as G, and which is shown in this present slide. Then the next slide. Slide number 9. In this slide, slide number 9, the previous slide. No. Previous slide. Not this one. Yes, selection criteria of working fluid.
Which slide? Thermal analysis, solar control.
Stop. Selection criteria of the working
Yes,
fluid.
this
Right.
one.
This one. The point which is mentioned in this slide should be taken into consideration to select the optimized organic working fluid. high efficiency and power output, low viscosity, high vapor density, high thermal conductivity. Then next slide. High condensing pressure, acceptable evaporating pressure, positive condensing gauge pressure, low melting point, high enthalpy, high convective heat coefficient, high heat capacity, low ozone deflecting potential, low global warming potential, high safety level, and good availability and low cost. Then for a scenario-based modeling approach, scenario 1 is a case study of calculating the coefficient of performance and cost estimation of constructing a setup on the rooftop of a house to fulfill the household requirement. Scenario 2 is a case study of calculating the coefficient of performance and cost estimation of constructing a small-scale factory in the hilly region of West Bengal. The electricity will be distributed from the factory to nearest 10 houses to fulfill their household requirement. The coefficient of performance is calculated by using a DWSIM open source software and the Prof in MATLAB environment. The targeted power output of scenario 1 is 1.5 kilowatt and scenario 2 is 115 kilowatt. The next slide. Some assumptions have taken into consideration during the simulation part. The ambient temperature is 25 degrees centigrade. The efficiency of turbine, pump, and generator is 70%, 85%, and 100%. And it is in steady state condition, negligible pressure drop across the expander, and condensing and evaporating pressure can be calculated from the saturation liquid at condensing and evaporating temperature. The evaporating pressure can be varying from one working fluid to another working fluid. Next slide. 4 organic working fluids are shortlisted according to their molecular weight, critical temperature, critical pressure, normal boiling point, atmospheric time, lifetime, ozone deflecting potential, global warming potential, and availability in the Indian market. Then next slide. The variation of net power output and thermal efficiency with evaporation pressure are shown in this slide and the next slide. And it is shown that the next power output as well as the thermal efficiency increases with the increase of the evaporator pressure for all working fluid. If the evaporator pressure increases, then the enthalpy of the expander increases, but the working fluid mass flow rate decreases. So the net power output increases. For working fluid in pentant produce a higher net power output and thermal efficiency with lower value of evaporator pressure compared to the other working fluid. Then next slide. Next slide, then next slide. In this slide and the next slide, the variation of the net power output and thermal efficiency with the turbine inlet temperature is shown. For every working fluid, the net power output increases with the increase of the turbine inlet temperature. For dry fluid like R245FA, in pentane R1233 ZDE, the thermal efficiency decreases with the turbine inlet temperature. For dry fluid, superheating is not required and it increases the exergy loss. For R11, which is an isentropic fluid, the thermal efficiency increases 3% by increasing the turbine inlet temperature. This means the dry fluid already leave as a superheated vapor, therefore no attention needs to pay for the vapor quality. The working fluid in pentane provides the high thermal efficiency, which is 8.62% at a low turbine inlet temperature, which is 460 Kelvin. Then next slide. Then next slide. The variation of heat addition to the evaporator and with turbine inlet temperature and the heat rejected by the condenser with the turbine outlet temperature are shown in this slide and the next slide. R11 has a highest heat addition rate and heat rejection rate, and R245FA has lowest heat addition rate and heat rejection rate. Then next slide. Next slide. The coefficient of performance, net work output, and other calculations part of both for all working fluid is shown in this slide and the next slide. This is for the scenario 1 and then next slide. This is for the scenario 2. Then come to the next slide. Based on the Indian market scenario, the cost estimation is providing in this present slide for 2 scenarios. It is pertinent from the cost estimation part that the solar collector and the turbine hold the maximum cost of the entire system. Then next slide. The performance of work is to identify the availability of solar powered organic ranking cycle unit in the Indian climate scenario. The objective can be categorized as identifying 4 suitable organic working fluid based on the indicating factor as mentioned in this paper, the parametric evaluation of each fluid in order to identify the operational envelope, and the basic system scale cost estimation for the working fluid for offering the best power output. Then next slide. Some key findings in the article are summarized in this present slide. For both cases, N-pentane offers the lowest flow rate requirement, where the other fluid requires the highest max flow rate. The evaporator pressure requirement is on average within the range of 18 to 34 bar. For both scenario, R1233 ZDE offers the best efficiency, which lies in between 8 to 8.3%. The specific system cost can be higher when the targeted power output is 1.5 kilowatt. Next slide. Presently, solar organic ranking cycle considered in this analysis is the simplest version of the organic ranking cycle. We investigate that the achievable performance could be improved upon using some advanced technology like regeneration, etc. Furthermore, the cost estimation of system majorly depends on the solar collector and the turbine. The selecting and optimizing those components suitably for such application could further bring down the cost sustainability, thus leaving a pulsating scope for the future research. Then the next slide. I'm very much thankful to Professor Bijan Kumar Mondal for his constant support, and I am also thankful to Professor Shondeep Saha and his graduate research assistant Arindo Mondal from the Department of Aerospace Engineering, IIT Kharagpur, for their constant support during my summer internship program. And the project helped me in gaining the initial foundation in formulating a possible way forward of this research problem. I will be addressing under the supervision of Professor Bijan Kumar Mondal from Department of Mechanical Engineering Department, IST Shivpur. Next slide. Thank you everyone for listening my presentation, and please feel free to ask me if you have any question.
Thank you very much, Ayana. I appreciate the fact that you plowed through all the difficulties. I will just allow one question. If there is any question for Ayana before, yeah, Dr. Niyogi, yeah.
Anna, my name is Dr. Praveen Yogi. I'm speaking to you from Canada, like Professor Biswas. Congratulations on an excellent presentation. There's not enough time for a full discussion. I only wish to say to you that people like Professor Biswas, Dr. Arup Bhattacharya, and I are most interested in your research. We would be happy to follow up further with you. And I hope that you will be able to write up your research into a paper, which can later be submitted to an academic journal. Nihar, I think you can make this promise to all the others who succeed as well.
That goes for everyone. Yeah, thank you. Thank you very much. Okay, in the interest of time, we are going to move on to the next presenter.
Thank you, sir.
Thank you. Thank you. Sorry, and I can't see you, so I really didn't. Okay, great.
Just a minute. Yes, thank you, sir.
Thank you very much. Thank you. Yeah. Next, I would like to ask Shishir Chaudhary, Ravipati. ETC fourth year. Winner of the Ashok Kumar Sharkar Undergraduate Fellowship donated by Mr. Avik Sharkar, IIT Kanpur alumnus, California, USA. Somebody going to manage his slides? I know that he only has about 12 slides, so should be good. Should be within time. Thank you. Shishir, can you control your presentation now? Or?
Yes, so just a sec.
Okay.
Am I audible?
Yes, we can hear you, but there is a little bit of disturbance in your microphone, I think.
Okay, so I'm just trying to share it. So is my screen
Sure.
visible?
Yeah, we got it.
Yeah, all right.
Thank you, Professor Biswas, for that kind introduction. So I'm starting with the presentation. So first of all, hello everyone. I'm Shishir Chaudhary, a fourth year undergrad from the Electronics and Telecommunication Department. And today I shall be presenting my research paper on a zinc oxide humidity sensor integrated with an IGZO, indium gallium zinc oxide thin film transistor based preamplifier. Okay.
You can show your video also. Let your video come on as well.
Yes, Professor.
Yeah.
We will go in the following order. I'll first introduce the background, talking about what motivated me, and I'll be moving on to the design of the zinc oxide humidity sensor. Next, I will discuss the design of the IGZO thin film transistor-based preamplifier, which I've used, and compare it with existing similar works. Then I shall proceed on to the results and their significance. As we all know, humidity monitoring has become essential in vital industries like food processing, construction, and biomedical analysis. So real-time and efficient humidity monitoring is of utmost importance, and this can be done using humidity sensors. For instance, in large man-made structures like airplanes, detecting humidity levels is very important to evaluate the threat of leaks due to corrosion to its hermetically sealed body, leading to decaying mechanical structures and electronic system failures, leading to casualties. In recent years, owing to significant health and environmental monitoring applications, the demand for wearable electronic devices has been growing rapidly. However, to be applicable to such devices, the humidity sensor needs to have the properties of flexibility, transparency, and must be fabricated at room temperature, which are features uncommon in traditional sensor systems. This is what motivated us to develop a humidity sensor, keeping such applications in mind, which produces robust output signals of wide range and is highly sensitive and linear in nature. In recent years, metal oxide semiconductors have gained prominence in sensing applications due to their excellent isoelectric, electrical, and chemical properties. Among such materials, zinc oxide proved to be a good fit for humidity sensing due to its high electronic mobility, good electrical conductivity, and low cost. Zinc oxide has been preferred especially here in the form of nanorods and nanowires, which can provide a much larger surface area with the same volume than in other forms of zinc oxide. Here we prepare zinc oxide nanorods using a two-step hydrolysis process. In the first step, a zinc oxide seed layer was formed on the substrate by forming a sol gel method. The second step involves growing zinc oxide nanorods onto the seed layer, which serves as a nucleation center. Moving on to the methodology of the humidity sensor, to measure accurately by employing self-calibrating and error correction techniques, We have used here Wheatstone bridge as the readout circuit and employed the fabricated structure onto a quadrant of the bridge here, with fixed resistances occupying the other quadrants. The readout circuit is integrated with IGZO TFT amplifier to improve the output signal strength for the signal processing. Under voltage influence, this sensor equivalent circuit acts as a humidity sensor as per the given equation, and this voltage is amplified across the bridge is amplified, and this is the output voltage. Now, a thin film based preamplifier is preferred over a conventional MOSFET due to both sensor and amplifier on-chip integration. We use IGZO layer as the TFT channel due to its excellent mobility, good transparency, and carrier concentration. The op-amp design implemented involves a two-stage topology, with the first stage exhibiting a high gain and the second stage exhibiting a high output swing. For the first stage, we prefer a simple telescopic cascode topology. We prefer this topology over a folded cascode topology to reduce the larger static current and noise contributors in a folded cascode structure. A telescopic cascode op-amp can be used efficiently even at higher frequencies and has low power consumption than other design topologies. A common source amplifier was utilized in the second stage as the high output swing stage. Differential amplifiers were not preferred as they could be leading to a lower output swing. In addition to that, Miller compensation has been used in order to maintain the stability of the preamplifier. Now we have compared this design preamplifier with existing such similar TFT-based amplifier works. We can see that on performing AC analysis of this work, the design achieves a DC gain of 54 dB, a 3 dB frequency of 3.4 kilohertz, and a unity gain bandwidth of 66.52 kilohertz. We can observe from the analysis that our design has a comparatively better gain and bandwidth than the other models at a lower supply voltage and power consumption. Now, to test the robustness of the design preamplifier, we have used process voltage temperature (PVT) analysis. We record the deviations in the 3 dB cutoff frequency and the gain of the preamplifier on varying the supply voltage, temperature, and the width of the TFTs. Interestingly, we find no noteworthy change in the gain and the 3 dB frequency of the preamplifier. That is, the relative change is less than 1%, which implies that the designed preamplifier shows robustness towards process voltage and temperature variations. Now, the assembled humidity sensor is placed in an AH202 sealed high or low temperature humidity test chamber to expose it to different levels of relative humidity to analyze the sensor performance in the presence of a preamplifier and without it. It can be observed that the amplified output voltage at the preamplifier decreases from 464 millivolt to 332 millivolt as relative humidity changes from 10% to 90% with an increment of 5% relative humidity during each measurement. The curve exhibits a close to perfect linear behavior over the entire RH range. It is important to note that the designed gas sensor system, along with the preamplifier, has a wide dynamic output voltage range of 132 millivolt, which helps the sensor to overcome its drift and make it less error prone. Now, defining sensitivity as a particular relative humidity using the formula above, we have calculated the sensitivity for various relative humidity levels when the humidity sensor is employed with the designed preamplifier and when it is implemented discretely. We can observe that as relative humidity increases, the sensitivity of the gas sensor system increases almost linearly, which makes it an excellent feature for practical applications. There is also an improvement in the sensitivity of the sensor when we use a preamplifier. This is evident by the increase in the slope of the preamplifier curve when recorded with, of this sensitivity curve when recorded with the preamplifier. To conclude, we have demonstrated that the assembled sensor portrays close to perfect linearity over the examined range of relative humidity, that is 20% to 90% relative humidity levels, and shows good thermal stability as well as a swift sensor response. Amplification with the designed preamplifier yielded a sensitivity and a gain significantly higher than previous studies and provided a stable, discernible output signal for further logic processing. This model also inhibits the properties of flexibility and transparency in the sensor design, which makes it an excellent feature for emerging electronic applications. These are some of the most important references we have used in our paper. Thank you for this presentation, and a special mention to GAABESU and our alumni for this beautiful initiative. So I'd like any questions?
Thank you very much, Shishi. And I like this slide, the last one.
Yes, sir.
All right. I will entertain at least one question from the audience.
Well, Shishir, this is Arup Bhattacharya. I enjoy your presentation and congratulations. Very good piece of work.
Thank you very much, sir.
Yeah. Any other question? No? I hear none. Well, in that case, Shishi, thank you so much, and keep up your good work. Thank you.
Sir.
All right, thanks. Yeah, right. Good presentation. Well, that takes us to the next winner, which is Somesh Lairi Chakraborty, EE 4th year, winner of the Soirendra Kumar Sen and Indra Sen Memorial Research Award donated by Mr. Subir Sen, 1964 CE, USA. Somesh, you are on.
Yes, thank you, sir. Sir, I'm now sharing my screen.
Yeah, please do.
Is my screen visible, sir?
Yes, we can see it.
Good evening, everyone. I am Somesh Lairi Chakraborty of 8th semester Electrical Engineering of IIST Shibpur. I thank GAABESU for this honor, and at the same time, I am grateful to the esteemed alumni for this opportunity. Whatever I have learned, it is solely due to the knowledge imparted by my teachers in IIST. So now I am moving over to the next slide. So these are the details of the research work which I have done while in my final year in IIST. The first one is titled as Analysis of Spherical Microphone Array Beamforming Techniques and its Detailed Studies, which I did under Professor Rajesh Hegde of Department of Electrical Engineering of IIT Kanpur. Next is the work titled Detailed Analysis of 6 MPPT Techniques on 3-phase grid-connected photovoltaic system, which has been accepted for presentation in the IEM RE 2022 conference. The third work is a novel approach to detect power theft in a distribution system using machine learning and artificial intelligence.
Wow.
And this one is basically an extension of my final year project, which I am doing under Dr. Abhinandan De of IIST Shibpur Electrical Engineering Department. This has been accepted for presentation in CIPR 2022. And finally, I have this work and analysis of harmonic distortion in line current of power system by Pony analysis, filter analysis, and study on power quality indices. Now, as I move on to the next slide. So this is the title of my research work, Analysis of Spherical Microphone Array Beamforming Techniques and Detailed Studies. I did this under the Surge Internship Program of IIT Kanpur under Dr. Rajesh Hegde of Electrical Engineering of IIT Kanpur. So basically, what is a beamformer? And beamformer is basically an efficient and useful method to convey information with important applications in many fields like 5G technology or wireless communication. The basic difference between a beamformer and a normal antenna is that while a normal antenna transmits the signal uniformly in all directions, a directional beamformer enhances the signal in one particular direction, whereas it attenuates the sound from other sources and which are coming from all the other directions. Now, in this research work, we have studied various variations of a beamformer, and also we have conducted research on the features of a beamformers. But due to the time constraint, I have only incorporated a few important ones and this select few. Out of those, I would like to discuss the axis symmetric beamforming. We also want to strike a balance between the maximum directivity beamformer and maximum WNG beamformer. We also have the minimum variance distortionless response beamformer and the LCMV beamformer. Now, so this figure 1 demonstrates the what we mean by the maximum directivity beamformer. Here we can see that as the order increases, as the order of the beam pattern increases, the directivity also increases, or the sound becomes more enhanced in one particular direction. Figure 2 demonstrates the maximum white noise gain beamformer. White noise gain is usually used as a measure of array robustness. It is defined as the improvement in sound to noise ratio at the array output compared to the array input. And this figure demonstrates a maximum WNG beamformer. Now what we do is that we basically want to strike a balance between a maximum directivity beamformer and a maximum WNG beamformer. For that reason, we go for a Dolf-Chebyshev design of a beamformer. Here in figure 4, we can see that as we are decreasing the scaling factor, we observe that the side lobes are increasing in size, whereas the central lobe is decreasing in size. So we can say that although the directivity is improved, the sound coming from the other sources are also given some importance, which may lead to some degradation of the sound quality. However, when you are increasing the scaling factor, the width of the central lobe increases, leading to loss of directivity. However, the sound coming from other sources are heavily attenuated. So basically, we want to strike a balance between directivity and WNG. Now, as we move on to the next slide, this shows the an MVDR beamformer, which is basically whose ultimate goal is to minimize the variance of the beamformer output. So basically, if the noise and the underlying desired signal are uncorrelated, this type of beamformer seeks to minimize the sum of the variances of the desired signal and the noise. Now I go on to my next work, which is titled as a detailed analysis of 6 MPPT techniques on 3-phase grid connected PV system, which I did in collaboration with students from NIT Kurukshetra and scholars from IIT Roorkee. In fact, today morning only I gave this presentation in this IMRE 2022 conference, which is sponsored by IEEE and the Solar Energy Society of India. So basically, we know that in the modern world, as the load demand is gradually increasing more and more, we are becoming more and more reliant on renewable sources of energy like wind, solar, thermal, etc. The National Institute of Solar Energy has assessed that the solar potential of our country is currently at 748 gigawatt, and also it has set a target of 100 gigawatt capacity till 2022. This figure demonstrates the typical PV characteristic and IV characteristic of a solar cell. The most important aspect of this PV characteristic is that we try to extract the maximum power from this solar cell. For that reason, we have implemented 6 MPPT algorithms and compared them based on the stability during changing weather conditions, efficiency, time taken to track the maximum power point. This is the basic MPPT tracking system, which consists of a PV array, a boost converter based MPPT tracking system, and a 3-phase inverter with a 3-phase grid. So this figure 9 presents the flowchart of a perturb and observe algorithm, where basically this algorithm basically works by calculating the difference in power and voltage in consecutive steps of iteration or perturbation. Based on that, we decide whether to move in the same direction of that PV curve or in the opposite direction of PV curve. Now we have this INC algorithm, which basically checks the slope of the power curve, because we all know that at maximum or minima, the slope will be equal to 0 at maximum power point. From that, conclusion, we try to derive the MPP solution. And one of the most important algorithms we have used here is the beta method, which was proposed by Sachin Jain. What it does is that basically it calculates a variable, intermediate variable beta, which places the operating point very close to the maximum power point. And from that, we use conventional MPPTs like perturb and observe or INC to track the MPPT in small steps. Now coming to the results section, we have at first compared the 6 MPPT algorithms on the basis of steady state power ripples. We can observe that INC and variable state INC are giving us large power ripples, which vary between 2 kilowatt to 3 kilowatt. Perturb, observe, or hybrid or beta method give us relatively lesser ripples. Now, next we have compared the algorithms on the basis of the dynamic behavior of the MPPT algorithms under the changing weather conditions. We can again observe the INC and variable step INC are giving large ripples compared to PNO or beta method. BOC is itself an unstable method because it changes with the voltage amplitude, which is also changing with the changing weather conditions. Now we have compared the algorithms on the basis of power extracted from the PV cell. The red lines here basically denote the total power available from the PV cell, whereas the black lines denote the variable step INC, the power obtained from the MPPT tracking algorithm. We can observe that for the beta method, the two lines are almost coincident, which means that beta method extracts the maximum power from a PV cell even under variable weather conditions. Lastly, we have compared the algorithms on the basis of time taken to reach the steady state. We can observe that P&O method takes about 0.49 seconds, the largest among all the algorithms, whereas VOC or beta method INC takes relatively lesser time. Out of this, beta method proves to be the most robust algorithm. Also, it has the highest efficiency. So on the conclusions, as we already mentioned, the beta method converges fast and also proves to be a robust algorithm under changing weather conditions and grid dynamics. Now I move on to my third research work. This is basically a novel approach to detect power theft in distribution system using machine learning and artificial intelligence. I'm doing this work currently under Dr. Abhinandan De, Associate Professor of IIT Shibpur Department of Electrical Engineering. This one has been accepted for my presentation in 4th International Conference on Computational Intelligence in Pattern Recognition, which will take place in our IIST only in the month of April. So basically what we have done here is that we have at first collected the historical consumption data of 100 consumers of CESC for 2 years and validated that with the consumption data for the year 2020. After that, we have used 6 machine learning approaches like decision tree or random forest or SVM logistic regression on the dataset. And after the algorithms are adequately trained to recognize the historical consumption patterns of the individual consumers in the different times of the year, these trained ML algorithms can then identify any major deviation in the consumption pattern. And on the basis of that, the algorithm marks such deviations as probable cases of power theft. So here we have used the decision tree algorithm on 25. We have separated the consumer data points as 75 to train the algorithms and 25 to test our algorithm. We can see that 17 consumers are not committing any theft, and the decision tree algorithm also states that they are not committing any theft, whereas 7 consumers are committing theft, whereas the decision tree algorithm also states that 7 consumers are committing theft. One consumer here is false positive, or this consumer has basically not committing any theft. It's not committing any theft, but the algorithm says that he is committing any theft. So basically the decision tree gives an accuracy of 17 plus 7, 24 or 96%, as the confusion matrix clearly demonstrates. Here we have used the logistic regression. Logistic regression gives us an accuracy of 100%, whereas KNN gives an accuracy of 15 plus 6, 21, means 84% accuracy comes from the KNN classifier. Now here we have used the ANN algorithm, and instead of giving the confusion matrix in this case, we have showed how the accuracy of our model gradually increases with the number of epochs, and the mean square error gradually decreases with the number of epochs. The Keras API model of the TensorFlow of Python platform has been used to simulate this simulate these algorithms on the available data set. So this is the most important table. As you see that from this table, we can see how the algorithms perform. We can clearly observe the logistic regression gives the highest accuracy of 100% compared to decision tree of 96%, SVM at 96%, ANN at 96%, and KNN gives us the least accuracy of 84%. And these are the data points, how they have been classified. Now, as I move on to the next slide, this is my final work, which is the analysis of harmonic distortion in line current of power system by Pronis analysis, filter analysis, and study on power quality indices. I did this under Dr. Debjani Ganguly, Associate Professor of Department of Electrical Engineering of IIST Shibpur. Basically, this is the line current waveform of a RL load connected to a 3-phase supply system. And on this waveform, I have performed the first Fourier transform to get the harmonics present, like the 50 Hertz or the 250 Hertz or the 350 Hertz harmonics. And when we perform Froni analysis on the same waveform, we see that the harmonics present are 50 Hertz, 150 Hertz, and 250 Hertz. So this is basically my 4 research work. I thank everyone for giving me the undivided attention. And if anyone now has any questions, I will gladly hear those questions.
Thank you very much, Somesh. Oh, you are very busy working on a lot of different things.
Yes, sir. I actually like working on this research project because it gives me a lot of knowledge about many research work which are currently going on around in the world.
Sure, sure.
Nihar, if I might make a comment.
Yes, please.
Somesh, first, congratulations on an excellent presentation, and particularly the breadth and scope of your research activities. Personally, I was most impressed by your attempts to use AI and machine learning techniques to detect power theft, which I take it is a very major problem in India.
Yes, sir.
I do hope that you will go on to continue with your research activities, because it is very, very rare to find somebody at the undergraduate level to have one or more papers accepted and published at an international conference or in an academic journal. If we as alumni can help you in your further studies, please feel free to contact us. That is what we owe you.
Thank you very much, sir. Thank you very much for providing me with this opportunity.
Yes, Shomesh, this is Arup Bhattacharya. I totally second what Praveen Newdy said. And wish you all the best.
Thank you, sir. Thank you, sir.
Nihar, if I may make a comment, quick comment, please.
Absolutely.
Shomesh, first of all, I just echo Arupda and Praveen, congratulations. You did a very good job in terms of like your research output. Since you have used this supervised learning method, may I suggest that when you present next time, just to think the paper in terms of a hypothesis modeling, like say the CSC paper Praveen was talking about, right? So essentially from CSC's point of view, they might have a hypothesis that power theft is happening versus not, okay? So you come up with that null hypothesis and try to prove the alternative hypothesis versus not.
Yes.
So that would give a little bit of more structure to the paper. And the other thing is, since you have a lot of research output and you have assigned only 10 plus 2 minutes, so my suggestion would be like generate the slides in a way which are the key messages, no more than like 10 words in a line and no more than 10 lines in a slide. Okay, that might help you in terms of conveying your message in a more succinct manner. Thank you very much, and once again, congratulations.
Thank you.
Great
Sir.
job.
Thank you very much.
Thank you, Dr. Ghosh. Dr. Ghosh. Actually, that is applicable to everyone who are presenting today. That's a very important point. So that's very good. All right. So I think we are going to move on. Thank you very much, Somesh. Just for everyone, my email address, I'm going to leave it later on, and feel free to contact me. And I can distribute that to many of my colleagues, both in USA and in Canada. Thank you. Okay, so our next presenter is Sumit Kumar Ghosh, ME 4th year, and winner of the Nripendra Prasanna Acharya Research Award, donated by Sri Nripendra Prasanna Acharya 1960 CE, and resides in Modesto, USA. So Sumit.
Yeah, sir. Sir, can I share the screen, please?
Yes, you can. And if you can make yourself visible as well, right?
Sir, 1 minute. Give. Sir, am I visible? Hello, sir.
Sorry, yeah, you're okay. I can see you. I don't see the screen yet.
Okay, sir. Yeah, I'm presenting.
Thank you.
Sir, is it visible?
Yes, it is.
Okay, sir.
Thank you.
Respected alumni and all my dear friends, a very good evening to all of you. Today, I am here to present one of our conference paper. Basically, we're working on 2 conference paper. One will be presented by me and other will be presented by Subhajit, who is also a award winner for this thing. So, and I also like to thank GAABESU for giving me this awesome opportunity to have my paper presented before you. Before I start, I will take a moment to introduce to all my authors, Rahul Durai, Piyas Malik, Subhajit Biswas, and myself, Sumit Kumar Ghosh. We are from Department of Mechanical Engineering, Indian Institute of Engineering, Science and Technology, SIPPU. We are currently pursuing BTech, and we are in the final semester. I would also like to thank Dr. Aditya Ganguly for his constant support throughout this journey. Now, without any further delay, let's move towards the presentation. Our topic is mathematical model of a grid interactive system incorporating a solar parabolic trough collector integrated with a hydraulic accumulator system. In this presentation, we'll be seeing on the introduction, the literature reviews, the gap in the research and objectives, the schematic representation, the mathematical model, some assumptions, governing questions, resultant discussion, model validation, model interpretation, and the references. As modernization process is catching a fast pace in this world, the world seems to lean towards the non-renewable resources for its energy fulfillment. Figure 1 shows the gross electricity production by source, and this data is for 2019, and it was provided by International Energy Agency. These were the major literature we have gone through while we are working on our paper. First one was Castellanos, second Saka Tigwig, Galindo, Misra and Singh, Lattice, Stojic, and Kargar. While we are doing the major project, we have gone through many research papers, conference papers, magazines, and several works have been reported for hydraulic accumulation and renewable resources with conventional power integration. But no such work with hydraulic accumulator integrated system has been reported in Indian context as of now. The void in research gave us the objective for the project. So our main focus was to conceptualize the use of solar collector integrated with the organic Rankine cycle as a renewable power resources for space heating system, and to present a mathematical model that illustrates the functioning of a parabolic trough collector system, and to perform a validation of the model using the established literature and analyze the behavior of the model under the Indian climatic condition. The figure shows the schematic representation of the proposed model. The PTC cycle is coupled with a organic Rankine cycle using a heat exchanger. When solar radiance falls on the PTC, the energy is used up to heat the heat transfer fluid. The heated fluid is again used to heat up the ORC fluid by using the heat exchanger. Heat exchanger acts as a condenser for PTC cycle, whereas evaporator for ORC cycle. The heated water is used to run the hydraulic pump. The required speed is 1800 RPM. And the pump operates perfectly when the solar irradiance are in the range of 450 to 700 watt per meter square. But what happens if the solar radiance fall like it is above or below the prescribed range? Here comes the control unit in the control unit and the accumulator in the picture. When the solar irradiance is above 700 watt per meter square, then the control unit senses the increasing pressure in the hydraulic pump, thereby redirecting the extra fluid in the accumulator system. And when the irradiance falls below 450 watt per meter square, then again control unit senses the decreasing pressure, thereby releasing the extra fluid which was stored in the accumulator system to maintain the speed of the hydraulic pump. The accumulator used in this model is actually a bladder type accumulator system with modified control valve. The valve is added so that the redirecting of water should be gradual rather than a sudden flow of water. The whole ORC system is powering a power generator. During daytime when solar irradiations are available, the power generated is used to heat the space heating system, whereas the surplus energy is stored in the power grid. During night time when there is no solar irradiation available, then the power stored in the grid is used to heat up the space heating system. A mathematical model is based on the PTC cycle has been developed by us to study the performance basically. Section of the model dealing with the PTC cycle is presented, and this model is based on a report by R. Forrestal. These are some of the assumptions we considered during designing of the model. Some of the important are like uniform flow and uniform flux, negligible thermal resistance from absorber coating and glass envelope, constant thermal conductance and convection heat coefficient. Both radiation surfaces are gray, and the heat losses through the cross pipings and the end losses are considered to be negligible. These are the equations which were used by us. The main objective is to find TC out. In this case, in this equation, T1 is the mean temperature of the heat transfer fluid. Q3SAB is the incident solar radiation to outer absorber pipe surface. Q5SAB is the incident solar radiation to outer glass envelope surface. Q56CV is the convection heat transfer from outer glass envelope to the ambient. Q57RD is the radiation heat transfer from outer glass envelope surface to the sky. And all these variables are found using the following equations, which are given in the equation 2, 3, 4, 5, 6, 7, 8, 9, and 10. A mathematical model based on the ORC cycle has also been developed by us to study the performance. Section of the model dealing with the ORC cycle is presented, and this model was based on a report by Norman in 2012. These are the assumptions considered during the designing of the ORC cycle. These are the following governing equations of the ORC system. The main focus is to find the eta TH, the thermal efficiency, and the work mass flow. And eta TH in this case is given by W34 minus W12 by Q23. The constants and their values used during the designing of the paper. The model is also analyzed in MATLAB 2021 programming environment, and the output was compared with two established literature, namely Castellanos and Singh and Mishra. On comparing the fluid outlet temperature with the model proposed by Mishra, the maximum deviation is obtained was 10.99%, whereas with that in Castellanos is about 9.30%. The fluid outlet temperature is analyzed for the Kolkata data, and this was the graph we plot. This is actually a fluid outlet temperature as a function of the time of the day. The x-axis shows the time during the day. We carried out the analysis from 4 o'clock to 6 o'clock in the evening, and this was the graph we got. The table shows the model interpretation of the Kolkata data. The ORC, the table 3 shows the ORC system thermodynamic parameters, and the table 4 shows the validation of the ORC cycle. The efficiency of the system was deviated by a maximum of 11.75% and displayed the most at when operating at a 1,000 watt output power. This figure shows the ORC system efficiency as a function of electric power. The x-axis shows the ORC system efficiency, and the x-axis shows the electric power output. The conclusion is basically the study presents the integration of a PTC system coupled with a modified ORC cycle and a grid interaction mechanism. As the study was entirely theoretical, validating sections of the system with the published experimental and theoretical data provides valuable insights. The study thus reinforces the need and viability of such a grid interactive system comprising of PTC collector and a bladder accumulator based storage for operation in developing countries like India. These were the important references we used during the making of our PPT. These were the conferences we have participated till now. And the first one is the mathematical model of a grid interactive system. We participate. The conference was of IME 2021. It was presented on 17th December 2021. The second is the variable heat flow system, which will be carried on by Biswas. This was also presented in IME 2021, and it was presented on 18th December 2021. And the third one is the mathematical model of a grid interactive system. This was presented in international conference AME IIM 2022, and it was presented today only, 26th February in the afternoon. I presented it in NIT Raipur. Thank you all for your patience. Hope you all liked the presentation. Thank you, sir.
Excellent. Thank you, Sumit. Thank you very much. And I will entertain one or two questions from the audience. Please. Dr. Niyogi, I think, is your hand up?
No, I was clapping.
Okay.
I gave a thumbs up.
Thank you, sir.
Okay, great.
But congratulations. Congratulations again.
Well deserved.
Thank you, sir.
All of them. Oh. Okay, so anybody else?
Myself, Partha Chattopadhyay.
Oh, yes.
Sumit, congratulations for excellent presentation. I feel so excited that you people are participating in research at IIST Shibpur, and definitely I can see a bright future, right? So in line with Bimanda, I have a suggestion for you that yes, you have to maintain the text in a way so that the audience is interested to read that. And second thing, when you present a plot or graph, you should take care of the font size of the axis, title, and scale, because that is very important. Otherwise, people do not feel the importance of your data. But otherwise, regarding, construction of the results, presentation of your problem, deriving conclusion, it is really excellent. Thank you. Thank you very much.
Thank you, sir. Thank you, sir, for your suggestion. Thank you, sir.
Thank you. Okay, so anybody else? No? Okay, so thank you. Thank you very much, Sumit. So we are going to welcome Rivu Banerjee, our next presenter, ETC fourth year, winner of the Ashok Kumar Sarkar Undergraduate Fellowship donated by Mr. Avik Sarkar, IIT Kanpur alumnus residing in USA. Rivu, you're there? Okay, good. Yeah, we can see you. Yes, we can see you.
Hello, everyone.
Yes, and you can go ahead and share your screen. Thank you.
So I hope the screen is visible now.
Yes, visible.
Yes, yes.
So good evening, everyone. So I am Rivu Banerjee, and today I'm going to present the paper that has been published in IIT TCAD named Oracle, which is an Oracle-based attack on a cellular automata guided logic and locking. So this project was carried out under the mentorship of Raja Chubba Chakraborty, who is from IIT Kharagpur. So coming to the background of this project, it relies on cellular automata. So what is cellular automata? So cellular automata is the discrete lattice cells, which can be which is composed of storage elements like T flip-flops, and whose next state logic is determined by a combinational logic block. The combinational logic, which determines the next states of a CA, of a cellular automata, can be categorized into two categories. The first is an additive combinational logic, which uses only XOR or XNOR function gates for determining the next state, depending on the present state. And another is the non-additive logic, which uses AND or gates to determine the next state. Moreover, the CA can also be categorized depending whether the states belong to a cycle or not. So the first category is a group CSL, which are the CSLs which belongs to a cycle, and the non-group CAs are those which has both cyclic and acyclic states. So this work predominantly is on a particular special class of non-groups additive CSLs, which is named D1CA. And D1CA relies on these four particular rules: Rule 90, Rule 102, Rule 165, and Rule 153, which determines the state transition logic. So as the state transition logic only uses XOR and XNOR gates, it is a part of additive CSLs. On the right, we have a state transition diagram of a 4-cell D1CA. So as we can see, the green cells, the green colored cells are the reachable ones, and they belong to the cyclic states, and the others are the unreachable and the acyclic states. So coming to the D1CA and its dual forms. So as we saw in the last slide, the D1CA is governed by Rule 90 and Rule 102. The leftmost CSL transitions is governed by Rule 90, while the others are determined by Rule 102, and this forms a rule vector for D1CA. Coming to D1CA dual, D1CA dual CAs are those which can be obtained from the D1CA by complementing just one or more CSL transition logics for the next state. So D1CA dual is named for that CA for which the leftmost CSL is obtained by complementing the original function. So over here we are using XNOR operator. And for D1CA dual B, the third leftmost CSL transition is governed by the XNOR rule as well. So here we present the rule vector for both D1CA dual and dual A and D1CA dual B. On the right, we see the state transition diagram of D1CA dual A. We notice that the structure of the D1CA dual A resembles that of D1CA dual, D1CA, original D1CA, but it just, the structure remains the same, but the transitions are different. So coming on to the main properties of D1CA, as we saw, all the reachable states of D1CA are lies on a circle, lies on a cycle, so they are named as cyclic states. And all the D1CA states which are cyclic have an even number of ones in the binary representations. That is, they have even parity. Coming to the third property, the D1CA, whose number of cells ranges from 2 to the power k minus 1 plus 2 to the power k plus 1, has a maximum transition cycle length of m equals to the power k. The fourth property shows that if m, that is a maximum transition cycle length for a particular D1CA transition diagram, which has n number of cells, then we can say that all the factors of n, the set of transition cycles, cycle lengths for the particular D1CA are all the factors of n. From these properties, we reach a proposition that if an FSM which follows D1CA rule, starting from reachable state S, if we make m or any multiple of m number of transitions, the D1CA goes back to its initial state S. Next, we come to how D1CA has been used for obfuscating FSMs. So FSM states and transitions have been implemented using D1CA blocks. So we have a state transition, state encoding algorithm has been followed to assign FSM states to each state of the D1CA. Next, the transitions are governed by a particular control signal, which is C key. The C key, when it's 0, the state machine undergoes a D1CA transition in the normal mode, while when the C key is 1, the state machine undergoes a transition in the D1CA dual B mode. Since we're encoding states of the CA machine to that of an FSM, a number of unmapped state transitions could be possible. So to map those unmapped state transitions, we use a additional conditional logic named interrupt logic. So the interrupt logic outputs an interrupt vector that is called IV. Next, we take an example of a state transition to show how the IV helps in mapping unmapped transitions. So the IV, so over here we take a state transition from SI to SK. If we want to make the transition in the D1CA normal mode, the C key has to be 0, and the IV that is provided by the interrupt logic is FK XOR FJ, where FK and FJ are the state encodings of SK and SJ respectively. While if we use CK equals to 1, the state machine undergoes the D1CA dual B transition mode, and the corresponding IV is presented as FK XOR FL. So this is the overview of the architecture that has been used for obfuscating the CA-based FSM. Over here, we show a 4-cell CA state machine, and we have 4 control signals, which determines the type of transition the state machine makes. We have C test, C key, and C test, C key, and TE. So if we have C test equals 0, first of all, if we have T equals 0, then the CA state machine undergoes test mode transitions, while TE equals to 1 implies FSM mode transitions. In the state mode transition, if the C test is given as 0, then it is normal D1CA mode transition, while C test of 1 implies dual A transition, while in TE equals to 1 mode, if C key is given as 1, it undergoes dual B transition. The main thing that has to be noticed over here, the leftmost CSL has an observable output that is Q, and this has been rigorously, this has been predominantly used for attacking this algorithm. So as we discussed, the state machine undergoes 2 types of transitions in FSM and test mode. So FSM mode depends on C key, and the test mode occurs in autonomous mode, which is the normal D1CA and D1C dual A. The property that is being used for testing the CA-based FSM is that if we start from a particular state in the state machine and undergo m+1 clock cycles in dual A or normal mode, depending on the even and odd number of ones present, followed by a m-1 clock cycles in D1CA normal and D1CA dual A or D1CA dual A mode, the state machine returns back to the initial state. So over here, we give an example. If we start from this cell 1101 and undergo m+1 D1CA transitions, over here m equals to 4. So if we undergo 5 transitions continuously, and then if we undergo dual A transitions for m-1 clock cycles, we return back to this particular initial state. So we have the external observable signals for this FSM are the sequence of leftmost CSLs and the primary outputs. So this provides a high testability, and it eliminates the scan-based DFT technique for this particular architecture of FSM. And the QS, the sequence that we observe for the leftmost CSL is unique to each FSM state S of an N cell CA. So over here we have a particular sequence of transitions, and if we take the leftmost bit of every transition, we get the QS m+2 sequence. So we show how this QS m+2 sequence can leak the information of the state encoding, which was supposed to be a secret. So over here, we present a particular example. So if initially for a 4-bit FSM, if the initial state of the CA machine was F, whose bits configuration was F1, F2, F3, and F4, after in the first initial transition, we have the leftmost bit observable. So the bit leaked is F1. If we make a D1CA dual A transition, we reach the state F2, and over here we see, according to the rule of the D1CA, the F2 bit is observable at the leftmost element. So the F2 bit is leaked. And consequently, if we make further transitions, the entire state encoding of the initial state has been leaked. Like bit F1, bit F2, bit F3, and bit F4 all are leaked after undergoing 4 transitions in the dual A mode. So in the adversary model, we have the locked netlist, which can be accessed by which is locked netlist as well as activated chip from the market. The activated chip is used as the oracle for performing the attack on the obfuscated FSM. And so the adversary can be anyone who can simulate the locked netlist with arbitrary input vectors. And the attacker only gets to know the externally observable leftmost CSL value for each state. So the attack overview consists of both test and FSM modes. So in the attack, we utilize the vulnerability introduced by the test mode. So in the initial state, we gather the state encoding information of the initial state by gathering the QSM+2 sequence for that particular state. So we have the state encoding of S0. After that, we make an FSM mode transition from S0 to S1. And again, to gather the state encoding of S1, we again obtain the QS1, M2 sequence for S1. So we have both the state encodings of the initial and the destination states of the FSM. And we can also give the input PI and the initial state to the interrupt logic to obtain the IV value. So we have over here from S0 to S1, we can use the state machine uses IV1 to make the transition, whereas for the particular C key equals to 1 case, the IV2 has been used to make the transition. So depending on the IV value that has been generated, and we can back calculate the IV value as we have both the states encodings. So if we see the IV1 matches with that of the IV we have calculated, so we can infer that C key has been 0. Otherwise, if it matches with that of IV2, we can conclude that the C key is equals to 1. So in the case 1, as we mentioned, so the interrupt logic is not encrypted. So if we make a transition from S0 to S1, and we obtain the IV from the IV circuit, and we can infer that what key has been used to obfuscate that particular transition. In case the IV circuit has been encrypted using XOR or XNOR gates of length Tk, the main challenge was that we don't have a particular oracle to perform the SAT attack on the encryption logic circuit. But since we discussed that we can obtain the state encodings and back calculate the IV values, we can create the oracles for the transitions and obtain the encryption key using SAT attack. And over here, we discussed the experimentation results we have performed on the MCNC benchmark circuits. So 20% of all benchmark transitions were locked using C key equals to 1, and the interrupt logic locking was done using 20-bit key K. So we have listed a few of the MCNC circuits over here, and the number of transition that has been used, that has been required to obtain all the C key values that obfuscates the FSM. So over here we present the value number of transitions that has been used to obtain the C key for 20% threshold, and 40% threshold respectively. So Oracle presents the vulnerabilities that the externally observable CSL can present that obfuscates the entire FSM. This paper presents a novel attacking algorithm that can extract the secret key for every transition in an CA guided FSM obfuscation technique harnessing the above observability. The future work can be extended where the C key values can be multi-bit instead of just 1 bit. So thank you, everyone.
Thank you, Rivu. Excellent presentation. Just one question I will take. Anybody has a question for Rivu? No? Okay, well, thank you very much. And all the best with your research.
Thank you, sir.
Okay, good. Yeah. So we are going to welcome now Devsundar Dey, metallurgy 3rd year. late Madhusudan Bhattacharya Memorial Research Award, donated by Dr. Dilip K. Bhattacharya, 1961 EE, from Philadelphia, USA. Devsundar, are you there?
Hello, sir. Am I audible?
Yes, you are audible. You got around
Yes.
10 minutes, okay?
Yes, sir.
Please
Yes, sir.
Thank you. Thank you. Yeah, we just see your still picture, not live picture. We can see your slides, but not you.
Yes, sir. Can I start?
Yeah, you can start. Yeah,
Yes,
sure.
sir. Yes, sir. My name is Devsundar De, and currently I am a third-year undergraduate student from the Department of Metallurgy and Materials Engineering. Today, I am going to give a presentation on phase prediction of high entropy alloys using machine learning approaches. The other authors of these papers are Dr. Manojit Ghosh, Dr. Amitabh Choudhury. So this is the other research work that I have done, mechanical properties of crystalline and semi-crystalline polymers that have already published in Encyclopedia of Materials, Polymers and Plastics, and other research works, prediction of mechanical properties of steels using machine learning, that has been accepted by Materials Today proceedings through the International Conference of MMETF 2021 and Indian Institute of Metals. Due to lack of time, today I am going to give presentation on the first one, that is phase prediction of high entropy alloys using machine learning approaches. So I would like to start my presentation with a great quote by Dr. B.S. Murthy, currently a director at IIT Hyderabad, from his book High Entropy Alloys. The English language insists on unalloyed pleasure, thereby implying that the sensation of pleasure must be pure and not admixed with other emotions. Exactly the opposite rules in metallurgy, where pure metals have few uses but lot more upon alloying. So here we can understand the importance of alloying elements on the materials. So let us first start with the definition of high entropy alloys. High entropy alloys are basically the alloys as where we can mix 5 or more principal elements having equal atomic percentage or near equiatomic ratios. In a broad sense, these are preferably defined as those alloying content to 5 to 35% alloying elements. And second definition is from the approaches of entropy, where entropy should be greater than 1.5R. And here the basic fundamental principle is we can see that here if we plot the graph of entropy and composition graph, we can see at the midest of the graph we can get the maximum. So the entropy, so if we are allowing something, so entropy get increased, which helps decreasing the free energy. So this is the principle of high entropy alloys. And I would like to carry out my other slides with some questionings. Like first questioning is what is the motivation of the work and what is the basic aim of this work? The main motivation of this work, actually the exceptional behavior of high entropy alloys, like its fatigue property, its thermal property and other mechanical properties also. And the main aim of this work is to predict the phases that may be either solid solution or intermetallic or amorphous. So why phase prediction is important? Next question is, phase prediction is important because phases, phases decides the mechanical character. Like if it is intermetallic, then it's going to be brittle, and if it is solid solution, then it gets the solid solution strengthening. So why machine learning? Why not other